Okay, on your mark, get set, go. Here we go. Today we want to talk about converting from rectangular form to polar form and from polar form to rectangular form. Again, you're in charge of putting your notes together for this, so what you choose to write down for your notes is up to you. This is probably pretty important. So if you want to go from r theta to xy, then you're going to use the formulas we list here. And if you're going to go from xy to r theta, then you're going to use these formulas here. Okay? So let's consider the difference between xy and r theta. Suppose that I plot a point right here, and we call this xy. That means I move a certain number of units in the x direction, and I move a certain number of units in the y direction. That point also has a distance from the center that we call the r value, and it has an angle that's formed that we call theta. Give me a relationship between x, y, and r. X squared plus y squared is equal to r squared. And thus you can see its connection in trigonometry at this point, right? So please, that's something that's review, right? That's not new. Don't get that wrong on the test. What is a relationship that exists between x, y, and theta? We solve that argument, tangent theta is equal to y over x. We solve for which quadrant it's in. Obviously, it's going to be in the second quadrant. It's negative over there. You can see that. We've seen that before too, haven't we? Like that's our fourth time of seeing that, right? So we saw that in chapter 5. We saw it twice in chapter 7. See it again right here. So it's all laid out for you. So if you want to be able to figure out theta, you want to be able to figure out r, those are what you use. Suppose that you want to figure out x and y. Well, somebody give me a relationship that exists between r theta and x. Cosine. Cosine of theta is equal to what? X over r. Multiply both sides by r and you get x is equal to r cosine of theta. Remember when we talked about vectors, that was the horizontal component of the vector. Same thing exists right here. What's a relationship that exists between y, r, and theta? Sine. Sine of theta is equal to y over r, or y is equal to r sine of theta. So you can see those are important to find x and y, and these are important in order to find r and theta. Very good? Okay. Example 2. So the first thing you have to do on your test is you are going to have to be able to plot and name polar coordinates. That's what we did yesterday. Second thing you're going to have to be able to do on the test is you're going to have to be able to convert coordinates to rectangular form. Okay? Meaning we want x equals and we want y equals. Well, in this situation, x is going to be equal to, this is r and this is theta. And the formula says we take the radius, which is 4, times the cosine of 2 pi over 3. And y is going to be 4 times the sine of 2 pi over 3. I want exact values. On the last test, some people were putting estimations. I don't want that. So I want to come up with the exact value for cosine 2 pi over 3 and sine of 2 pi over 3. So that means I got to go back to my unit circle. 2 pi over 3 is how many degrees? 120. So that means I got a 60-degree angle left over there. What is this terminal point? Negative 1/2 of root of 3 over 2. So that means that x is going to be equal to 4 times negative 1/2. And y is going to be equal to 4 times the root of 3 over 2. Well, 4 times negative 1/2 is negative 2. And 4 times the root of 3 over 2 is going to be 2 roots of 3. Now, this didn't completely kind of work. This didn't work out last time. We got to make it work out this time, okay? We got to have sense in our minds to be able to decide, is this a reasonable answer? And on the last test, we were not able to do that. If you were to graph this, does everybody agree that you go, let's see, 1, 2, 3, 4, okay? So you would turn 2 pi over 3, which would bring you right about here, and then you would go 4 units in that direction. Everybody agree that that would be about the coordinate? Yesterday we talked about plotting that. Everybody knows that, right? Is this in the second quadrant? Yeah. So don't give me an answer that's in the third or fourth or first quadrant. Okay, you know it's supposed to end up in the second quadrant. You checked it, and it looks like it should be higher than it is, horizontal. And you can see, this number is bigger than that number in terms of its absolute value. So yeah, I think if you were to plot this on a rectangular coordinate, if you were to, right back 2 and up that many, you would end up at the same spot. So they should end up at the same spot. Okay. You do the next one on your own. Go. Gotcha. All right, x is equal to negative 2 times the cosine of 5 pi over 4. And y is equal to negative 2 times the sine of 5 pi over 4. You had to find the exact value for 5 pi over 4. 5 pi over 4 was how many degrees? 225. So that coordinate right there is negative root of 2 over 2 and negative root of 2 over 2. So negative 2 times negative root of 2 over 2 and negative 2 times, and negative 2 times negative root of 2 over 2, same thing. So negative times a negative is positive, you just get the root of 2. And negative times a negative is a positive, you just get the root of 2. So that's your coordinate. Which quadrant is that in? First quadrant. Let's think about it. Should this be in the first quadrant? If you rotate 5 pi over 4, that brings you this way. And if you go negative 2, you go in the opposite direction, right? So that brings you to the first quadrant. See that? You got to check that out. Sure works. Questions on that? Going once, twice. Think what you want. There you go. All right. Find the polar coordinates of 3, negative 3. So this is xy right now. This is xy, and we need to put it in terms of r theta. And we've got 2 formulas. This is going to be very, very normal for you to see. Number 1, we need to compute r. And r is equal to the square root of x squared plus y squared. So I just modified the formula by taking the square root of both sides. We know how to do that, right? So I have r is equal to the square root of, what is x squared? 9, and y squared? 9. So we get r is equal to the square root of 18. Can that be simplified? That's equal to 3 roots of 2. Okay, we all make mistakes. Hannah's laughing at your mistake. Hannah, we don't make fun of people for making mistakes. We applaud the effort. What is this? What kind of dog is this? It's your dog's dog? You can hurt the dog. There you go. All right. Okay, whatever. Yeah. All right. Now we got to find theta. So we said tangent of theta is equal to what? Y over x. And y over x is going to give me negative 1. Okay? So, where is tangent negative? In which quadrants? Second quadrant, fourth quadrant. If I inverse 1 on my calculator, you get 45 degrees. You tell me, is this the second quadrant or is this the fourth quadrant? this is the fourth quadrant, which means this would be 315 degrees. So theta is equal to, in radians, 7 pi over 4. So your coordinate is 3 roots of 2 and 7 pi over 4. Your r value and your theta value. We've done that 3 different times in this class. That should be 100% review, which is why this next test, everybody can get 20 out of 20. But I'd be lying if I said that everybody was getting that kind of problem right, even though we've done it before. Here's your chance to learn it. You try the next one on your own. Go. What up? All right, I'm going to go over it. R is equal to the square root of. Some people have a tough time squaring this. If you square -5, you get 25. If you square the root of 3, you get 3. And 25 times 3 is 75. So -5 roots of 3 squared is 75. And if you square 5, you get 25. Okay, got to be able to figure that out. 75 plus 25 is? And square root is 10. So your r value is 10. Then we set up the tangent of theta is equal to the y value, which is 5, divided by the x value, which is -5 roots of 3. Notice how those divide, and I get -1 over the root of 3. Now, I'm not going to leave that as my answer, but I am going to go to my calculator on this, and I'm going to do tangent inverse of 1 divided by the root of 3. I'll leave off the negative, and I get 30 degrees. In which quadrants is tangent negative? Second and fourth. So I have a 30-degree angle in the second and the fourth quadrant. Is this in the second quadrant or the fourth quadrant? Second, because you go back and then up. So this is a second quadrant. So this angle is 150 degrees. Convert that to radians, and it is 5 pi over 6. So therefore, you have the coordinate 10, 5 pi over 6. Are you good with that? Okay. All right, your last 3 examples here. Okay. Now what we want to do is we want to take equations for different graphs that are rectangular form. We'd like to convert them into what we refer to as polar form. And so all we do is we make a substitution, and the substitution is x is equal to r times the cosine of theta, and y is equal to r times the sine of theta. Now, people get confused with this because they're wondering, should we solve for r equals or theta equals? And I'm going to try to do my best to show you what the heck we do and why, all right? If we were to graph that, what shape would it make? A line, right? I mean, this is y is equal to 1/2 x. Everybody agreed? If you were to graph y is equal to 1/2 x, notice how the r value changes all the time, but the angle always stays the same, doesn't it? So we should come up with theta equal to just something in this situation. And that will be produced for us. Watch how this works out. If I plug in r cosine of theta, I get r cosine of theta is equal to r, or I'm sorry, 2 r sine of theta. I just plugged in r cosine for x and r sine for y. Both sides have what variable? R. So I'll divide it off. I get cosine of theta is equal to 2 sine of theta. I want to solve for theta. What should I do to both sides? Seen it before. Divide by cosine. What do you end up with on the left-hand side? 1. What do you end up with on the right-hand side? 2 tangent. And if I divide both sides by 2, I get 1/2 is equal to the tangent of theta. So if I'd like to find out what theta is, all I have to do is do an inverse. I go to my calculator, and should my answer be in degrees or radians? Radians. So if you go to mode and you select your radian measurement there, okay, your radian measurement, you can simply just tangent inverse 0.5 and you produce 0.46. Theta is equal to 0.46. And we said that if you consider the graph of 1/2 x, that it would look like that, right? So 0.46 theta is equal to is accurate, okay? Well, if you want to know that, then you can just multiply by 180 and divide by pi, or you could just switch your mode back to degrees and do the same thing, and it will show you. And we take that same entry, we get 26.56 degrees. That's it. The next one is more interesting. In this situation, what graph does it, yeah. Theta equals 0.46. So we want an equation that involves r and theta instead of x and y. And in this situation, the r completely disappeared. Theta is what remains. You're going to see the opposite situation here. Does anybody know what graph that makes? It makes a circle. An ellipse would be if we had different numbers on the bottom. But if you did divide by 25, look at what you would get. It's nice to see x squared over 25 plus y squared over 25 is equal to 1. That does look like an ellipse, doesn't it? Except when the bottoms are the same, it produces a circle. This is a circle with a radius of 5. Yeah, the radius is going to be 5. So watch how we could come up with an equation for this in polar form. I'm going to take and plug in r cosine of theta for x. And then I will plug in r sine of theta for y. That's equal to 25. Notice if we square this, we get r squared cosine squared of theta plus r squared sine squared of theta is equal to 25. Anybody see the little trick I'm going to do next? Before I do that, I have to starts with an F, rhymes with actor. Factor. Factor out that r squared. Aiden, what did you suggest cosine squared plus sine squared is equal to? 1. Notice how this is 1. So you get r squared times 1 is r squared is equal to 25. Hattie, what can you now do to both sides? Square root, you get r is equal to 5. Take out your calculator. Notice how we made a prediction ahead of time that we'd come up with r is equal to 5, didn't we? Go into mode and go down to polar. Make sure you're working in radians, not degrees, and select polar. Okay. Is a circle a function in terms of x and y? Does it pass the vertical line test? No. But watch what happens here. If we select polar and then you go into your y equals, it's now producing r values. And our equation is r is equal to 5. You simply plug in 5, and your calculator has this incredible ability at that point. Whoop. Sorry. I'm going to press zoom 6 to bring it to a standard viewing window. And what does it graph? Doesn't really look like a circle though, does it? That's because your screen is wider than it is tall. Agreed? So you could also do this cool thing called zoom square, and it squares off those dimensions, and now you do get a perfect circle. So your calculator can produce things that are not functions in terms of x and y, which actually with the use of parametric and polar equations, we can actually create graphs for every existing thing on the face of the planet. That burrow tree out there, you could come up with an equation in parametric form, be very complicated, but maps exactly the growth of that exact tree. It's pretty remarkable. Our calculator doesn't have that option. We do have a way to work around it, but watch as I show you the next one. We're actually going to graph a vertical line, and that might help you a little bit. So we go to our last example of the day, and that would be x is equal to -2. Now, I tried to give you guys an idea of whether we're solving for r or for theta. In the first one, it was just theta is equal to, and the second one was just r is equal to. This next one is a vertical line. It passes through x is equal to -2. So just think about this, for example. If you have a point on this graph, okay, look at the red point and then look at the green point, okay? Are the r values the same or different for the red point and the green point? Are they the same or different? They're different. So r is changing. Everybody agrees? How about the angle? Is the angle the same or different? Different. That angle's changing and the r value is changing, right? So you're going to have both r and theta in this problem. Whereas in this situation, r was always the same. So it was just r equals. In this situation, just theta is the same. It should just be theta equals. So we're not going to try to get too complicated with these examples, but I just want you to try to be intuitive about what you're thinking about. So all we do is we just take and plug in r, cosine of theta, is equal to -2. And you can see by your calculator, most of the time we like to solve for r equals. In order to solve this, we just take and divide both sides by cosine. We get r is equal to -2 divided by the cosine of theta. Or in other words, I'd accept either answer on the test, but r is equal to -2 secant of theta. These are both acceptable answers. -2 over cosine is the same as -2 secant. Watch what happens when I go to my calculator and I plug this in. I go into y equals, and it says r is equal to -2, and we don't have a secant button, so we have to do divided by the cosine of theta on our calculator. And then as we press graph, notice how it produces for us a vertical line, which before was impossible for us to be able to graph. Question, Hattie. Theta is the same as the x, y, t right here. Yep. And it turns out that there's all sorts of cool things that you can graph within polar form. If I graph cosine of 5 theta, I get a really interesting graph. It's extremely small, and if I insert a number, say like 3, let's see what we get now. Let's insert a larger number. Let's insert 7. Oh, I inserted 73. My bad. That's a little crazy. Sorry about that, YouTube people. Let's go y equals and get rid of that 3. Let's look at the graph. Huh, it's like a flower, isn't it? For Mother's Day, you could produce a flower on your calculator for your mom. Say, hey, Mom, I love you. There you go. There's your flower. You might want to like make supper or do dishes or something too. Like that might not go that far. But you can produce all sorts of cool shapes here. And you could just watch what happens when you change these. I had 5 petals. Maybe if I go 7, I'll get 7 petals. I don't know. Would we get 7 petals? Oh, you do. Isn't that interesting? You could actually take this and branch off of it and do a go 11 instead, and see if we can make it bigger. Yeah. Crazy thing too is you can actually control the graph. This is one thing that's really interesting. Look at our theta value is 6.28. That's 2 pi, right? So that's once around the circle. Watch what happens if we cut it to half of that, or 3.14, which is halfway around the circle. Watch what it produces. Oh, it still produced the whole thing, didn't it? Yeah. You can actually change the way that it it draws in increments as well, like how fast it goes. This theta step thing, if I have 0.01, watch how slowly it graphs this. It's like how often it takes a step. Look how slow that is. That's pretty slow, isn't it? We'll let it get done, and I'll show you the one more that we can change here. It's kind of fun. Okay, hurry up. I know I'm the one that made the equation. I shouldn't be. Looks like it runs out of space. Oh, there it goes. It connects. That was kind of cool. Go y equals here, and we go in our window. Instead of 0.01, if I change it to something different like 2, that's a big step. Look at the graph. It just draws a quick line there. I'll change it to 1. See if that makes. We'll go like 0.5. Come on. Look at that. Yeah, it's super quick. You know what I mean? You can actually control the way that it graphs as well. Lots of neat things you can do. But anyway, there you go. So you're ready to engage in that assignment. You really only have 2 assignments for this unit for you seniors. Maybe we'll get to a third. I doubt it. But Friday, I'm supposed to be gone for a track and field day. That day may not happen if it thunderstorms and rains. But we kind of have to do this same lesson over again tomorrow because of all the people that were gone for AP Language Comp. And then tomorrow, some people will be gone for AP Bio. So this is a lesson that I'll produce tomorrow. So you guys really, for those of you who are here today, you really have a work day tomorrow, if you know what I'm saying. Okay, fair enough? Negative 2 secant of theta. You got it, Hattie Adams. That's it. Track